In my previous video, I had seen system of differential equation, linear differential equation, how we have to solve any solution. Today, I will see some more example just as a review. But at first, I will highly recommend you please see today's video with pay attention. And if you don't see my previous video, at first see the previous video. Then today's video would be more clear. Because today just as a review part, I have given the link of my previous video in my description box. First question, which had come CSIR NET June 2023 exam. The question is, suppose xt is a solution of the following initial value problem in R2 such that x prime t equal to x with the initial condition x0 equal to x0 equal to x0, where the matrix A equal to this matrix. Here the question about solution. Here A equal to the matrix 5, 4, 1, 2. Then at first we have to solve the eigenvalue of this equation. Then this would be 5 minus lambda times 2 minus lambda minus 4 equal to 0. This implies 10 minus 5 lambda minus 2 lambda plus lambda square minus 4 equal to 0. That implies lambda square minus 7 lambda plus 6 equal to 0. That imply lambda square minus 6 lambda minus lambda plus 6 equal to 0. That imply lambda times 6 minus 1. That imply lambda minus 6 times lambda minus 1 equal to 0. That imply lambda equal to 6 and 1 be the eigenvalue of this solution. So the solution of this equation would be xt equal to c1 v1 e to the power 6t plus c2 v2 e to the power t. This is the solution. Here first option, xt is bounded solution for some x0 not equal to 0. Is it bounded solution? As t tends to infinity, xt always tends to infinity. So, when xt tends to finite value, then this would be the bounded solution. Here as t tends to infinity, since xt tends to infinity, so xt is bounded solution, this is be the wrong option. And option 2, e to the power minus 60 times xt, that means e to the power minus 60 here mod xt. That means e to the power minus 60 here mod xt means c1 v1 e to the power 60 plus c2 v2 e to the power t. That imply c1 v1 plus c2 v2 e to the power minus 5t. And as t goes to infinity, this value tends to 0. But given this value tends to 0 as t tends to infinity. This is not, because here C1 V1 and C1 is not given. So this value tends to 0. This is if C1 equal to 4, then this is not tends to 0. So option 2 also wrong option. Option 3, e to the power minus t times mod xt, and this is equal to e to the power minus t C1 V1 e to the power 60 plus C2 V2 e to the power t, and this value would be C1 V1 e to the power 5t plus C2 V2, and as t goes to infinity, this value tends to infinity. Then obviously as t goes to infinity, this value tends to infinity, but this is possible when this C1 is not equal to 0. If C1 equal to 0, then this value would be 0. So since here not given C1 is non-zero, so option 3 also wrong option. And option 4, e to the power minus 10t xt. E to the power minus 10t, here xt equal to C1 V1 e to the power 60 plus C2 V2 e to the power t. Then this value would be C1 V1 e to the power 16t plus C2 V2 e to the power 11t. Sorry, here e to the power minus 10t. Sorry. E to the power minus 10t. That means this value would be minus 60 and this value would be, this value would be minus 40. Just cancel this part. This value would be e to the C1 V1 e to the power minus 40 plus C2 V2 e to the power minus 90. Okay, and notice as t tends to infinity, this value tends to 0, also this value tends to 0, whatever C1 and C2. If C1, C2 both 0, then also this would be 0, or if C1 equal to 0 but C2 not equal to 0, then also it goes to 0. If C1, C2 not equal to 0, then also it goes to 0. So option 4 is a right option. E to the power minus 10t xt always goes to 0 as t goes to infinity for all x naught not equal to 0. I hope my all viewers have understood this question. Okay? Oh well. Next solution, which had come CSIR NET 2011 exam. Here A equal to this matrix. This is the solution. Option 1, the coefficient matrix A has a repeated eigenvalue. Option 2, there is only one linearly independent eigenvector. Option 3, the general solution of the ordinary differential equation is from these types where x1 is this and x2 is this. And option 4, the vector x1 and x2 are linearly independent. For this, here 3 minus lambda, 2 minus 2 minus 1 minus lambda equal to 0. That imply 3 minus lambda times minus 1 minus lambda plus 2 equal to 0. That imply minus 3 lambda plus lambda plus lambda square plus 2 equal to 0, that imply lambda square minus 2 lambda minus 1 equal to 0, that imply lambda equal to 1 and 1, this repeated root. We all of us know when repeated root, then how look like the solution. That means the coefficient matrix A has repeated root. For repeated root, at first solve the geometric multiplicity. Geometric multiplicity is n minus rank of A minus lambda I, means here lambda is here 1. Then this would be 2 minus rank of A minus I, and A minus I means 2, 2 minus 2, here minus 2. This rank is rank of A minus I is 1. That means this value is 2 minus 1, this value is 1. So, since geometric multiplicity also 1, that means for this eigenvalue, repeated eigenvalue, there is only one linearly independent eigenvector. And the vector is look like 2, 2 minus 2, 2, that imply 2v1 plus 2v2 equal to 0, that imply v1 plus v2 equal to 0, that imply v1 equal to minus v2. So the vector would be such type v1 equal to minus v2, here v2. So the vector would be minus 1 0, sorry, minus 1 1. Okay, so option 2 is a right option. There is only one linearly independent eigenvector, and the general solution is look like, we all of us know how look like the general, how would be the general solution. Here this would be A minus lambda I, here lambda equal to 1, 2, 2 minus 2, 2. Here the vector is considered generalized eigenvector, considered xy equal to this vector minus 1 1. Notice here the eigenvector given in the option 1 minus 1, but here I have got minus 1 1. If we multiply, if we common minus 1, then this would be 1 minus 1. So this is for solution, since given option 1 minus 1, so this is 1 minus 1. Then this would be 2x, here minus 2, 2x plus 2y equal to 1. That imply x plus y equal to half. That imply x equal to half minus y. If we consider, or y equal to half minus x. If you consider x equal to t, then that imply y equal to half minus t. Then the solution would be, if x1 equal to 1 minus 1, then x2 would be t half minus t. I hope my all viewers have understood. That means 1, 2, 3, and the vector x1 and x2 are linearly independent. 1, 2, 3, 4 are right option. I hope my all viewers have understood this type of question easily. Okay, well. Today I will stop here. In my next video I will discuss again system of linear differential equation. Okay, because this type of question actually very important for any competitive exam. Okay, see you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.